video is going to be a video dedicated to solving the focused IPQs for the end of year exam, June 2025. So let's start with the first question. Of course, it's made of 44 questions, and we're going to be starting with the first question, which is from topic 3.1, acceleration. So the question is, the motion of a particle is described in the velocity versus time graph, shown in the figure below. Over the 9-second interval shown, we can say that the acceleration of the particle. So, first of all, what we have is um, velocity versus time graph. And the slope in a velocity versus time graph is equal to the acceleration. But here we have a straight line. And straight line means that the slope is equal to a constant. So this means that the acceleration is constant because we have a straight line and it's a velocity versus time graph. So acceleration is equal to a constant, which is answer D. Let's move to the next question. In the next question, we have, again, a velocity versus time graph. And in this velocity versus time graph, we have several portions. Excuse me. So we have several portions. They're asking about when is the acceleration zero. Acceleration zero means that we have a constant velocity. And constant velocity means that the velocity versus time graph is a horizontal straight line. This horizontal straight line is only at B. It's horizontal. So the answer that we pick is B. Now, they're asking about negative acceleration. Negative acceleration means that we have a negative slope. Negative slope means that the line should be something like this. It's sloping down. So sloping down shows you a negative acceleration. We have two of them actually. We have C and D. In both cases, acceleration is negative. But in our options, we only have C. So we pick C. Next question. 3.2, motion with constant acceleration. The first question here is that in the position time graphs that we have, which of the graphs represent an object moving with positive acceleration? They said positive acceleration. A is positive. Okay. Positive acceleration means that speed is increasing, speeding up. Speeding up means that the slope is increasing. So increasing slope. The increasing slope looks something like this. I'm going to draw it for you. Here the slope is increasing. So here we can say that becomes steeper. The graph becomes steeper. So in which case the graph is becoming steeper? The only case is B. All right. Now, another question. In the next question, they said, which of the graphs represent an object moving with positive velocity? Positive velocity means that the position is increasing. Actually, in B, D, and C, the position is increasing. So it could be any of those. In A, it's not even moving, it stops at its position. So the position is not changing. Negative acceleration means that velocity, not velocity, let's say speed is decreasing. Speed is decreasing means that the slope is decreasing. So decreasing slope. Decreasing slope, I will show you how it looks like. The graph becomes shallower like this. So here, when the graph is becoming shallower, it means that the slope is decreasing. So let's write here, becomes shallower. So in this case, I can tell already which graph is representing an object moving with positive velocity and negative acceleration. It's D. Number 6. The graph below represents the motion of a car during a 6-second time interval. So they're asking about the displacement, the total displacement. So total displacement is delta x equals to area. We have to know that when we have a velocity versus time graph, the area under the graph is equal to the displacement. But here I'm going to be cutting the graph into two parts, area 1 and area 2. So we have area 1 plus area 2. Now area 1 looks like a triangle, so it's going to be base times height over 2, the area. Now, how much is the base? The base is between 0 and 4, which means it's a 4, times the height is a 10 divided by 2. 4 times 10, 40 divided by 2, 20 meters. Now, area 2 is a rectangle. So we have length times width. Length is 10, width is between 4 and 6, it's 2. So 10 times 2 equals to 20 meters. So it means that we have 20 plus 20 equals to 40 meters. Then, using the equation, here it says a car initially traveling east with a speed of 5 meters per second is accelerated uniformly at 20 meters per second squared. So we have VI equals 5 meters per second, and we have the acceleration 2 meters per second squared, and the time given is 10 seconds. And they're asking us during this time interval, which is 10 seconds, how much is the total displacement? So if you have xf equals xi plus vit plus half at squared, you can bring xi to the left-hand side. It becomes xf minus xi, and this is nothing but the displacement delta x, which is going to be equal to vit plus half at squared. So your delta x is going to be 5 times 10 plus half. The acceleration is 2, the time is 10 squared. All of this is going to be on the calculator. It's going to give you 150 meters. So it's answer D. Then we have a second one, which is uh, again using the same equation in number 8. So it says in a race, a runner traveled 12 meters in 4 seconds. So we have delta x is the 12 meters during a time of 4 seconds. And it started from rest, uniformly from rest. So the initial velocity is 0. And they are asking about the acceleration. Again, we can apply exactly the same formula, which is xf minus xi equals to delta x equals to vit plus half at squared. Now, delta x is nothing but 12. Vi is 0. The time is 4 seconds plus half a, because we don't have a. The time is 4 seconds squared. Now, uh, 0 times 4 is nothing but 0. So 12 would be equal to half times 4 squared. 4 squared is 16. 16 times half is 8. A. Then we divide on both sides by 8 in order to get the acceleration. 8 and 8 are simplified. So acceleration would be 12 divided by 8. 12 divided by 8 is 1.5 meters per second squared. All right, so it's B. The answer is B. Next,